Okay, welcome Year 12s back to another video. This is looking at depreciation. So in the past, what we've looked at is something increasing in value. So this might have been looking at, say, an investment increasing in value over time, given a particular interest rate. Or we might have looked at the price of something increasing over time. So that would have been looking at inflation. What we're doing with depreciation is the opposite. We're looking at the item or an item decreasing in value over time. And just like interest, we've got a flat rate of depreciation, which is the equivalent to or the opposite to simple interest, but we also have a reducing balance depreciation, which is a little bit like your reducing balance loans, in that they are decreasing over time. The value is decreasing over time, but that is a little bit different because what that will look at is the amount of depreciation, or the rate is on the value of the item, as opposed to with flat rate depreciation where we just look at the cost price. So that's the main difference. The flat rate of depreciation is a percentage of the purchase price of the item that is being reduced, that is depreciating, whereas reducing balance is the percentage of the current value. And so obviously that current value is decreasing over time. Unit cost depreciation is a little bit different. This is looking at the depreciation depending on how much the item has been used. So depending on the use of an item. A couple of terms before we begin. One is that the value at any given time, so time in years, could be like 5 years, 10 years, 15 years, we call that the book value. So if I said find the book value of the item in 10 years, you're simply finding the value of the item after the 10 years of depreciation has occurred. The scrap value, that's when you no longer want to use the item. It might be faulty, it might just be beyond its life, and you will be selling that item at that point, and we call that the scrap value. First, we'll look at flat rate of depreciation. Like I said, it's very similar to simple interest, but just the reverse is happening. Instead of earning the interest or being charged this interest over time, we're looking at this depreciation being reduced. So it's being subtracted from the purchase price of the item. You'll see here that the formula just there, PRT over 100, is exactly the same as the simple interest formula, but of course this is looking at the amount that will be subtracted rather than the amount that will be added. So that's how we find the depreciation. We have the P for purchase price, R for the rate per annum, and T for the time in years. So what this is going to do is it's going to take our purchase price, multiply it by the percentage that it's going to lose each year, and then multiply that by how many years. If we wanted the value of the item though, if we wanted the book value, remember I said that's the value at any particular time, what we would do is we'd subtract this depreciation, the amount it's been reduced, from the purchase price. Therefore, this simplifies it somewhat. The book value will be the purchase price minus the depreciation. So let's have a look at this in practice. If I've got a company buying a machine for $15,000, this is my rate over here, 20% of the cost price. So remember I said with flat rate depreciation that it will be the percentage of the purchase price or the cost price that is being depreciated. So you want to look out for those keywords. So 20% of the cost price, we want to know what's the amount of depreciation. If you want the amount of depreciation, you are finding D. So it was purchased here for $15,000. The rate was 20% and the time, 4 years, is given in the question. So let's work out how much has it depreciated in those 4 years, and you should get $12,000. This is telling you it's lost $12,000 of its value. Therefore, if I wanted to find the book value, that would be the original price or the purchase price minus this $12,000 which has depreciated, and we can see that the value of the item, of the printing machine I should say, after the 4 years comes out as $3,000. Now what we can do is we can actually graph this. So if we wanted to show the depreciation schedule in a table, we can say, okay, after the 4 years, it lost, so the depreciation was $12,000 and its book value at that time was $3,000. Now, what happens with flat rate depreciation is that it loses the same amount every year. So if it lost $12,000 in 4 years, it means it must have lost $3,000 every year. So $3,000 in the first year plus another $3,000 for the second year would make $6,000. Add on another $3,000 and you can see every year $3,000 is being lost of the value of the printing machine. This means that after 1 year, if it was $15,000 to begin with and it lost $3,000, its book value is now $12,000. And we can subtract $3,000 each year, and you can see the book value or the value of the item is reducing by $3,000 each year. We can graph this. If you have a look at this, I've got book value on my y-axis, time in years on the x-axis. I'm just graphing for these 4 years. And I've just done this in thousands of dollars just so that my scale isn't jam-packed full of numbers. What I've got up here is when time is 0. So when time is 0, that's the original value. That's the purchase price in there. The y-intercept. That will be the purchase price of the item. Or it's book value when time equals 0. It's another way to explain it. If I graph that over time, so I've just graphed these book value against time 1, 2, 3, 4, what you'll see is we do get a straight line. Just like with simple interest, we had a straight line. Obviously, it was with a positive gradient, and with this one, obviously, the book value is decreasing over time. So we have a negative gradient, but it is a straight line. So flat rate depreciation, flat rate of interest, we get a straight line when we graph it. Let's have a look at another example. What we've got here is Jared buying a car 5 years ago. So there's our time. Time is 5 years. He bought it for $15,000. So there's our P. And it's got current market value. So at the moment, the book value, it's $7,500. Now, assuming flat rate depreciation. So it's telling you what kind of depreciation to use here. Let's find the car's annual depreciation rate. So this means find R. Now I know that book value is P minus PRT over 100. I can substitute these into the rule. R is what I'm trying to find, so that's what I'm going to solve. So solve for R just using your calculator, and you'll see we get 10% per annum. So this car here is losing 10% of its value every year, which is quite a lot if you think about it. When will the car have a value of $3,000? So let's have a look. If the book value is $3,000, when? So it's asking for T, time. Same formula that I used above, but of course now I know the rate of depreciation, so now I can put that into my rule. Rate was 10, and we're solving for T this time. Solve for T, use your calculator. What we have is T is 8. So after 8 years, the value of the car is $3,000. You can see cars do depreciate by a lot. I want to now look at reducing balance depreciation. So this is similar to compound interest, but in reverse. So instead of a certain percentage of the value being added every single year, it's this a certain percentage being subtracted every single year. So what we can do is we use a formula. It does look very similar to the compound interest formula, but you'll notice this here is subtracted. That rate will be subtracted from 1 to give us that particular it's not the growth rate really because it's being reduced, but it's like a reduction. What are we multiplying by to reduce this purchase price by a certain percentage each year? It's a bit of a mouthful. Okay, so we've got book value. Notice that in this formula you will get book value. If you wanted just the depreciation, you would have to use this formula, which is looking at the difference between your purchase price and the current value. So that will tell you how much it's dropped by. Okay, so we need to have a go at this. And I've just rewritten the formula down there so that we can complete this question. A transport business has bought a bus for $60,000. There's our purchase price. It's depreciating a rate of 30% each year. It's losing 30% of its value every year. So this is a reducing balance depreciation. If it said it's depreciating a rate of 30% of its cost price or 30% of its purchase price, that would be flat rate. So you are looking for those keywords. This one's saying it's losing 30% each year. So let's find out the book value after 5 years. Substitute these into the formula. So 30% for 5 years at $60,000. And what you get, or what you find, is that the value of the bus has depreciated quite significantly. 30% a year is a lot. So what we've got here is after 5 years, the bus is only worth $10,084.20. Let's work out how much it's lost of its value. That would be the depreciation. And that's the purchase price minus the book value, so or the current value. And what we get is $49,915.80. Just like before with the flat rate, I'm going to have a look at the graph of this. I've filled out the table mostly. I've used the formula and I've used it for time is 1, 2, and 3 years. And these are the book values that I've got and these are the depreciations I got. So just using the same workings that I did just up here, but instead of having a 5, I've done it for 1, 2, 3, and 4. Okay. Now I've just realised that I've left one out because I should have 5 there and I'll fill that in a moment. Okay, so I've done that for that same formula for each of these. So for 4, 3, 2, and 1, and these are the results here that I've got. So for 4, it actually came out as this, and for 5, this was our value here. And if we have a look at, we can add our last one in. So 10,084.20 was the book value. And 49915.80. Okay, now what I can also do is I'm just going to get rid of this one because I think I might have graphed that one a little bit wrong. What I can also do is I can add this to a graph with book value and time. So what we've got here is 1, 2, 3, 4, and I might just add 5 down there if I possibly can. I'll do that in a moment. Starting off when time is 0, the value of the bus was 60,000. After the first year, we'll see it drops to 42. Then we drop down to 29. So I'll just fix this up. Do it as I go. Might be a bit better. Okay, so 29 after, so 42, then 29. So it's dropped a bit. 29 is about there, isn't it? Third year, 20,000, just above 20,000. You can see that my graph is quite rough. to 4 years 15 or 14, sorry. And after 5 years 10. What you should be able to see is we're getting a curve happen here. It is the opposite to our compound interest. Remember, our compound interest went up like that. This one is coming down. So what we've got, that's compound interest. What we have is not a linear relationship, but rather a curved, it's an exponential decay really, but what we've got is the book value over time decreasing, yes, but it's not decreasing at the same rate, is it? If we have, well, the rate is constant, but the amount of depreciation is actually reducing over time. You'll see it lost most of its value in that first year, but then it actually lost a little bit less. In that next year, a little bit less again, a little bit less again. And what happens is you'll see that this depreciation slows down quite rapidly. So the depreciation started our first year was 18, but then it wasn't 18 in the second year, if you have a look at that. And in the third year, only about 9. Then it's only about 6, then only about 4. So the depreciation itself is reducing over time. The rate is the same, but it's the rate of the current value, which is why we have this curved relationship here. So we're just doing that so you can see the relationship. And yes, you would maybe or perhaps have to interpret some of these graphs. In terms of drawing them, you can see it is relatively easy just to set up a table of values and then to plot them on a graph. You can do it on your calculator as well. The final one I wanted to look at is unit cost depreciation. And this is instead of looking at time, so instead of looking at how old it is, we're going to look at how much the item has been used. And this is particularly good for things like cars. If you've got a car that has say you're comparing two cars. One of them has travelled 200,000 kilometres, one has only travelled 50,000 kilometres. Despite the cars being the same age, you would go with the $50,000 car. The one that has travelled, 50,000 kilometres, because it hasn't driven as far as the other one. So the parts in the engine, they might be in a better condition. So the value of that car is likely to be greater than the one that has travelled further. Let's have a look at how we can calculate a couple of things. First of all, we can look at the unit cost. This is how much is that item depreciating for each time it is used. So what we do is we take the total cost of the item altogether, or the amount that has depreciated over its life. So this is the depreciation. And we divide it by how much it has been used. And what we'll get is an amount or the depreciation per use. In other words, that's what the unit cost represents. Okay, so that's the depreciation in dollars, sorry. This here is the depreciation that we're finding all up. This is really, I shouldn't have really written depreciation because that's a little bit confusing, but this is sort of how much the item has cost you. So this is purchase price, and this is how much you're selling it for. How much have you spent on the item? That's probably a better way to describe it. So how much have you spent on the item divided by how much it's used, and that's the cost that you're giving, or that you're paying, I should say, for each time that you use that item. Okay, so if we have a look at the depreciation, we take the unit cost. Okay, so the value that it's going to lose every time that you use the item, multiplied by how many times you have used it. Let's have a look at this example down here using that formula. Taxi is bought for $31,000 and it's depreciating by this amount. Have a look, that's cents. So what we really should do is convert that to dollars. because we want our answer in dollars. Any unit cost that you use should be in dollars so that your depreciation answer is in dollars. So what we can do is take our unit cost and multiply it by how much it's been used. And if you have a look there, that is our amount of use, and therefore this is the amount of the depreciation. So all up, the value has dropped by that amount. The value of this taxi has dropped by 4,434 in that 1 year. Okay, what we can also do is we have a formula here that's got scrap value in it. So with unit cost questions, quite often you can find the scrap value. I mentioned scrap value right at the start. I said it's when you want to sell the item, when it's no longer useful for you, you will sell it, and you might not get any money for it, but quite often there is a value that you will get for selling the item. So what we can do with other types of depreciation, you still can use scrap value, but it's actually in one of these formulas for unit cost depreciation. So sometimes you can find the scrap value. In this one, we're not actually going to do that. What we're going to do is find how many kilometers are traveled. So what we'll do is we've got the unit cost. That was given in the question. We also have the purchase price. That was P. The scrap value is $12,000. And what we can do is solve for amount of use. So let's do that now. And that is in kilometers. So the car has travelled, or the taxi, oops, when it reaches its scrap value. So that is when the taxi driver will sell it. So it gets to that when it's worth $12,000, he might like to sell it at that point, because beyond that, perhaps the taxi will start to need repairs, perhaps. So he will sell it for a good price at $12,000, and at that point, it's only done the 66,901 kilometres, which isn't too bad. What I want you to do is practice with these questions here. If you do them in that order, it means that you'll do the flat rate questions first, flat rate depreciation, then the reducing balance, and then of course the unit cost questions. So if you've got any issues with this, please make sure that you come and see me in class.